Hi everyone, this is Abhisha and welcome to you all in another session of data analytics. So today we are going ahead with the further part of it, of our programming. Like we are going ahead with the same data set that we have taken for the Python programming, and we have taken all of it in details. So that data set only we are considering here for going ahead with the R programming, and then we'll go for the further steps of pre-processing, then visualization, as we already did for Python. Okay, the same thing, the same way we will be going ahead, but here we are just using the Python programming language, and some of the procedures would be different. Like what feature engineering may have we have done there, we are not doing it for our trying for some other feature engineering. This is how we are moving. Okay, so once you'll be seeing that, you'll be getting to know, and already I guess by now you have completed those sessions. So by now you'll be able, like when you'll be going ahead with it, you'll be able to compare that as well. So let's then go ahead. Let me just share my screen. Yeah. So hopefully my screen is visible. So okay, right. Okay. Yeah. So this is the thing that we have taken. So basically, if you can see here, we have just taken out the packages. So what are the packages? So as you all know, what we have already discussed in Python, the same thing. For a better version, I am just recalling the details that we have already discussed. So a package, you can think about a collection of ready-made tools that actually helps our actually here, because we are taking the package on part of our programming, okay, to do some of the special jobs that can be done easily without any effort, right? So for example, one package can do some of the cleaning stuff, one package can is good for the visualization, drawing the graph, one for summaries, one for relationship between the numbers. That's all. Okay, so this is the sections. So now, what does this install dot packages mean? Okay, so install means download and add. Okay, and packages means the, as I told, the toolbox that is useful for Python. So install dot packages means please download this toolbox and keep it in my system for further use. So this is the command that you are giving it to R. Okay, so that is how it is performing. Okay, so the very first package that we have used up, that is tidyverse. Okay, so what is tidyverse? Tidyverse is not one package, so it's a kind of big container, you can think of big box or big container that contains many small packages. Okay, so all of the small packages together in one single package, that is tidyverse. Okay, so this comes with tidyverse. So under tidyverse, we contain that dplyr, ggplot2, tidyr, that one, and we have the readr and tibble. Okay, so as we already have gone ahead with ggplot2 and dplyr, so dplyr that actually cleans and changes the data that you have already seen. Some of the major operations you can do using dplyr, this package. Coming down to ggplot, that is basically for going for the graphs. Next, coming down, tidyr is basically for making the data clean, okay, clean and neat basically. For that, we are using that. And read R is basically for reading files. And coming down to table is for the smart tables. Okay, so this is the thing. So tidyverse, why is this name? It is named it because the name must be written inside the code. That's why we are just writing the name inside the code. Like you can see, the name of the package has been given inside the code. Okay. Now we have gone ahead with install.packages. SKIMR, that is SkyMR. So that is basically helps us for quickly understanding the data set. So reading of the data set in the whole table, it tells how many rows, how many columns, average, minimum, maximum, missing values. For that we are using it. Okay. Now basically here, like you can imagine a big book with 1,000 pages. Instead of reading all books, SkyMR actually gives you the summary pages. So what is inside? How big is it? What is important? So that is coming under SkyMR. Okay. So coming down to the next package, that is install package ggalley. So ggalley is a friend of ggplot2, you can say. It helps in drawing many graphs together automatically, and the graph looks good and appealing as well, so that we can just get it accordingly. And also we have used that core plot. Core plot, it is basically shows the relationship between numbers using colors. So it shows the strong relationship, mixed relationship, positive or negative relationship. This kind of correlative plots we can use. We can plot using core plot. Okay. So this is the entire idea. Now coming down, like in case of, as you know, in case of in case of the pages, we have just taken it, we have used install dot packages right here. We have not used libraries. So install dot packages, it downloads the toolbox one time, and library actually opens the toolbox for you. Okay, so that is the major idea. So this was there, some of one was there. So I just re-downloaded it because this is the latest version of R. So I have re-downloaded the R Studio, and just that is the reason I need to reinstall it, and also need to show you this part. That's why I have just re-downloaded it. Okay. Now coming down after this, just coming down to df read.csv. Next, heart disease UCI.csv that we have taken, and then we have taken string as factors false. Okay. So basically what we are doing here, so we are the simple meaning of it is like I am telling R kindly open the data file and keep it in a container or in a box called df. So df is the variable, and I am just opening the CSV file and just storing the data in DF. Using like that is what we are doing. Okay. So let me just run it and see it how my data looks. So now you can see this is my entire data set, how it looks. We have already seen the data set beforehand in case of when you have just gone ahead for Python programming, there in details you have seen it, right? Now, breaking it down, we are getting this df. df is basically the variable. And here we are using read.csv. So read.csv, that is CSV, as you all know, it is the type, is a file type that is comma separated values basically. So I want to read the CSV file into the like in the table format, right? That's why. Now coming down to the head df, as you all know, head means top part. So it shows first 6 rows by default. So in case of Python, it is 5, but here it is 6. 1, 2, 3, 4, 5, 6. You can see. Okay, so that is the part. Now, after that, we are going ahead with strdf, that is, it shows me the structure of the data. Simply means like, tell me what is inside the data frame. Okay, let's just take it. So here you can see what are there inside the data frame. ID is the column name, int is the data type, how many rows are there that we are also getting, what are the names of the rows and what are the names of the data set. So it contains 920 observation and 16 variables we are getting. ID we are getting integer and the different integers we are getting. Along with that, we are getting a age variable. sorry, the column name as age, the type is integer type, and the numbers we are getting up here. Okay, so this actually shows us the structure of the data set. Okay, so you can think about opening an box and checking what items are inside, how many items are inside, what type of items they are. So this is exactly doing this str, that is the this str is not the string, this str is the structure. Okay, str we are like most often just take it as a string format, but here in R, str means structure. Okay. Now coming down with the summary DS, so it gives the summary of the data. So it gives a short report of each of the column. Okay. Let's just run it. Now here, or for all of the columns, it has given all of the details. Like for numerical columns, you have got mean, first quartile, median, mean, third quartile, max. For any of the for the categorical column, we have got what is the length, what is the class, like what is the type of data type, and what is the mode. So this is how we are good. We are going. Okay. So what is the mode means? What is the type of the mode? Data type of the mode basically. Yeah. Okay. So now after that, we are just going ahead with quick and smart summary. So that is for that we are using SkimDF. So here, okay, SkimDF. What is the error? Okay, I need to run the packages. So it is going. So it's still going. You can see, just you need to just have a wait. Yeah. Now here I'll run this. Okay. Could not find the function scheme. Why? Mm. Okay, let's install the package again. Mm. Just a moment, guys. It's taking our time. Okay, by the time let's discuss what the scheme does. Okay, so it gives us a better than the summary details. So it shows the number of rows, number of columns, the missing values, the mean, the minimum value, the maximum value, the data type, and all of the warnings. Okay, let's just open it. Okay, fine. Now let's just run it. Yeah, now you can see it has run properly. I guess it has not run before because I forgot to open that. Like the library, we need to just use the library SKIMR. So we have just downloaded it, forgot to open it. That's why. So we have just now taken it like that. And now you can see in details a report wise summary you have got it up. Okay. So what are the missing values? Where are the missing values against which column that you are getting? The completion rate, mean, standard deviation, PO, P25, P50, P75, like the percentiles basically, okay? And the quartiles basically, sorry, the quartiles basically, and the histogram plot. So the plots are also there, but since the space is short, it's not properly audible, like properly seen, like exactly, right? So that is the part. So now we are just going ahead with like this part is done. Now we are just going and finding, counting the missing values for each of the column. Though we have got this data from here, then also we just wanted to check it. So that's why we are just counting the missing values. So here you can get the counting the missing value for against each number of like each column name. So ID is 0, age is 0, gender is 0, data set is 0, CP is 0. Then TRES BP we have got 59, call we have got 30, FBS we have got 90, R REST ECG we have got 0, THAL CH we have got 55, X angina we have got 55, old PIF we have got 62, slope we have got 0, CA we have got 611, THAL we have got 0, and num we have got 0. Okay. Now I want to check for I want to check, like before that, I just want to give you the idea, like what we are doing up here. So we are using column sum, call sums is.nadf. Okay. So the basic meaning is count how many empty cells are there in each column, right? So is.nadf that checks every cell. If it is empty, we are getting true, else we are getting false. And then we are then call sum is activated there, and it adds up the true values as it has been as I have shown you exact the same in case of Python. The logic that is there, the same logic we are using here. So it adds up the true value. True is equal to 1 and false equal to 0. So in the final result, we are getting the column name and the number of missing value. Now the percentage of missing value. Like here we have got the number. Now we want the percentage of missing value. So it tells us how much data is missing in each of the column in percentage format. Let me check that. Like, let's check that. So now you can see for ID 0%, age 0%, gender 0%. Serious BPs, it is like 6.413 percent, and the major is coming out here for CA. That is 66% is missing of the entire column, right? So what we can do, either we can just drop off this column, or we can try to just figure out how we can just take the missing values there, right? So that is the case. Now here what we are doing up here, basically in this case the same thing we are doing as we are doing sum, but here what we are doing, here we are doing mean. So is.nadf that is doing the same as it did before. It is just going ahead and checking for each of the cell. If that is empty, we are getting true. If non-empty, we are getting false. The same thing as it we have done for counting the value. Okay. So now what we are doing, we are taking call means. That means it find the average of true and false. True equals to 1 and false equals to 0. So my result will come down in a fraction. Okay. Fraction of missing value. Right. And then we are just dividing, like multiplying that with 100, like that converts the fraction into percentage. Okay, suppose like the value is coming up around 10 divided by 100, right? So that is giving us the value as 0.1, right? So now what we are doing, that then we are just doing 1.0.1 into 100 to get the percent as 10%. Okay, so this is the logic, right? Basically here, yeah. So now after this section, what we need to do, we need to drop off the columns, drop the column slope. So what we are doing here, we are just dropping off the column slope. Okay. So basically, we have the column that is CA. CA, you can see the percentage is coming around 66.41. That is around you can say around 66 for 66%, 66.4%. So we are just because the number of if that is around less than 50%, we can try to fix this. But here you can see the value is going, like the missing number of values is going more than 50%, right? So it would be a better choice to drop off this column because majority of the data is missing, right? So we have to just drop off this. So DS dollar CA that access the column name as CA, and null actually gives nothing. Like that means nothing. So it assigns the null and removes it. Okay. So this is what it does. Now, why we are removing it, as I mentioned you. So too many missing values are there. So it is not useful because for majority of the values we are not getting the any proper value for CA. So it is actually causing the confusion. So it's better to drop it off. Okay. Now what we are doing now, we are checking for missing value again. Okay, let's run it. So now you can see for CA it is coming up. Okay, isn't we run with it? Okay, just a moment. I guess we haven't run this. So let's just run this. Sorry, just a moment. Just a moment. Okay, fine. Let's just run it. So we have run it. Now we have to check this. Yeah. Now you can see there is no CA column here. So we have just dropped it off. Okay. So now what we are doing, we have to treat the missing values accordingly. So like how we are doing it? So we have to just treat it accordingly. So we will be impute the numeric values with the median. So we have taken a variable that is numeric columns, and there we have just taken a vector where we have just stored all of the missing values, numeric rows, numeric columns basically. The name of the numeric columns. Okay, so that actually makes the list of the column that have the numbers and missing values. Okay, so now this numeric columns, it is the name of the vector specifically. C is of course the combined value, and inside the code we are just going for the column names written as text. Okay, so that is the thing. Now we are going for fixing the missing values. So fixing the missing values basically what we are doing up here. So we are just using for them we are just using the median value to go for the details. Okay. So now for each of the numeric column we will be replacing the missing value with the middle value, that is the median value. So we are just taking the for loop up here. So the loop starts and we are just taking it accordingly. So df call, that is, we are accessing the column using the name, and is.na is find the missing value. And then where it finds the missing value, it is just replacing it with the median. So as you know, median is the safe option because not affected by higher or lower values. So it is better to take it. So I guess you all know what is the missing values, like how it is working. Suppose we have got the data as 10, comma 20, then we are getting suppose a missing value, and then we are getting this like we are getting any other value, extreme value maybe 100. Okay, right? Now what it is doing, so the median is coming up as 20. Median is coming up as 20. So median is the middle value. So middle value is 20. Why it is taking as 20? Because there are four values if we consider this NA. So middle values are 20 and NA, the missing one, right? So we are just taking the average of the middle two values. So here, since the NA is there is no value, missing value, so the median is coming down 20. So here for the missing value, so NA will be replaced with 20. So now the updated one will be 10, comma 20, comma 20, comma 100. Okay. So this is how the things will work. Okay, just a moment. So from here to here. Okay. So this is how the things are moving. Now let's go ahead again here. Yeah. So this is how we are doing now. After doing this, we have to run it. We have run it, and now we will be checking for the missing value again. So now here you can see for the majority you have got the missing values. There is zero missing value. So here you have got the missing value only for FBS and X angina because these are the categorical values, right? So these are the categorical values. Now what you need to do here for the categorical values, so we will be replacing the and the missing values for this categorical columns using the mod value. Okay, using the mod value, we will be doing it. Okay, so here what we are doing get mod function b. So it simply creates a small machine that finds the most repeated value. So get underscore mod is the name of the function, and function b is the input of like b is the input, that is a column. Okay. Now what we are doing, we are using uni UV, that is which is max tabulate match v comma uni UV. That is basically the unique part of it, right? So it finds all the different values without repetition, and it's just going accordingly. So here basically in this case, for this we will be getting the value as V, that would be equal to C, like after going, like just for a reference, I am saying. So it will be coming as yes, then it will be coming as no, like how it has been written actually, like that. Then again, yes, like this, it will be going. Okay. And basically, how we will be taking the unique V, so UNIQ V, that would be equal to yes and no. Okay. So here basically we will be taking the double inverted commas. So just for okay. So this is how it will be taking. So this is my values inside, and I am just taking the unique values from here to here. Okay. I guess you have all understood about it. Now, what we are doing up here, we are just taking the categorical columns here. Oh, before that, what we are doing here, so we are doing unique QV that I already explained you. So we are doing here the match Q, match V comma unique V. So it converts the value into positions. Okay. Now coming tabulate. Tabulate actually counts how many types each has appeared. Okay. Now, which is the maximum one? I am just going according to that. So it finds the position for the biggest count. Next, we have this unique QV that returns the value at that very position. Okay. So how it is going? Like suppose we have the values as cat, dog, cat, and cat. Like just for a reference, I am telling. Now here what we are doing, so the mod value is here cat. Why? Because the number of cat is more. So we have counted it and the number is going out as like the number of cat is more in this whole data. And dog has appeared for one time, and we have got cat that is appeared for three times, right? So that's why we are considering the mode as cat. Okay, so this is what we are doing now. Coming down here. Oh, sorry. Yeah. Here, so we are getting the categorical columns. So categorical columns actually, so we are just making the list of the columns that contains the categorical values, not the numeric values. Okay. So why this column? Because they have yes or no or any type of data or any of the labels. That's why we are considering that. Now we are fixing the categorical value using the mod. So we are using the for loop here. So for call in categorical columns that we are using, and here we are finding the mod value, and then where there is a blank, in that blank it has been replaced with the mod value. Okay. So this is how it is going. Like we have to just run it. So we have run it. Now we will be checking the missing value again. So now you can see there are zero missing values. Okay. So we have got there are zero missing values. Now we have to just check the duplicates. So that's why we are just taking it up here. So there is zero duplicates that we have taken. So we are just using the function duplicated and we are getting the sum of it. So sum means it will add if there is duplicate values. We will be just getting the sum of it. How many duplicate values we are getting. Okay. So now what we are doing, we are converting the categorical columns to factors basically. So we are just taking all of the categorical columns up here. And then what we are doing, we are using this df categorical call, that is L apply df categorical call comma factor. Okay, so we are telling R that these columns are categorical, not numbers. L apply means apply function to many columns. Okay, that is why we are using L apply, and factors is like the converted values into labels. That is the part that we want to do. Okay. Now we are again wanting to check this str. So here we are getting all of the details accordingly. Like this is how my data is there, and I want to get the head. So this is how my data are there. Okay. Now I am just opening the dplyr library, and I am just installing this ggplot2. So already installed. So I'll just open that. So we have just taken it that. Yeah. So we have just taken it that. Now we want to go ahead and detect the outlier. Okay. So the same way we are just going ahead and detecting the outlier. So let's just take it. So here once, okay, let me just, yeah. So we have just plotted it basically. So plotted it mainly what we want to do here. We want to draw a box plot of for cholesterol so that I can see weird values if there is any weird value, right? So now how this box plot shows the outliers. The box is the middle 50% of the value. Okay. And the line inside the box is the median. So this black line is considered as the median, and we are getting many dots outside, right? These are the dots. So these are the actually outliers. Okay. Now we are just taking it with a box plot for T-rest BP. Okay, what's the case? Why it is not taking the same thing for resting? So resting BP outlier. Okay, sorry. So we need to just take it this. So this is basically for cholesterol. So we have just got this plot for cholesterol, and then we have checked for T-rest BP. So for T-rest BP, this is the plot that we have got. Okay. So both contains many outliers. Okay. The cholesterol and resting BPs as well. Okay. Now what we are doing, we have to treat this outlier. That's why we are just going and creating a function that is cap outliers, and that actually makes a machine that fixes the outlier for any column. Okay. So now here we are just taking Q1. Q1 is 25% of the data, and 20%, 25% of the values are below this range. That is Q1. And Q3 is quartile 3. na.rm, this is basically like ignoring the missing value. If there is some way there is any missing value, just ignore the missing value. Okay. So now we are finding the intra-quartile range the same way as we have done it in Python. So we are just subtracting Q3 minus Q1. So we are getting the intra-quartile range. The similar way we are finding the lower bound and the upper bound, that is Q1 minus 1.5 into IQR, and upper bound, that is Q3 plus 1.5 into IQR. Okay. Now we are getting this capping the values. So here basically if the value is too small, make it equal to the lower limit. That is what we wanted to do. And if the value is too big, make it equal to the upper limit. Right. In case of Python, if you can remember, we have just replaced it with the median value for any of the outliers. But here we are just taking it like replacing it with the lower limit. Okay, so this is called the capping outlier. So we are keeping all the data realistic without removing any of the value as such. Okay, now what we are doing here, so now we are applying the function. So we are applying the functions over here over this like over this cholesterol part and T-rest BPs, because there in the plot we have found the outliers. So we are fixing the outliers in cholesterol and resting blood pressure column. So now we can use the data safely because the box plot will no longer have this extreme point, so the outliers will be sorted now. Okay, so this is what we have done. Now we will be plotting one by one the plots. Okay, so okay, we have to run it. So we have run it. Now we want to go ahead for a histogram plot. Okay, so histogram plot, basically what we are trying to do here, we are just going for df dot is numeric. Okay, you can see here we are going is numeric. So it checks if the column and sees if the numbers is in the column or not. Okay, so we are using s apply. So here you can see we are using s apply df comma is numeric. So it checks every column and returns true if the column is numeric, false if that is not, right? So it is going and checking each of the column. If the column is numeric, it is returning true. If that is categorical, it is returning false. Okay, now we are taking subset only numeric columns, that part. So that is basically num df, that is equal to df numeric, like comma numeric columns, right? What if it makes, what it means? That means it makes a new table that only contains the that only contains the number column. So df comma numeric columns tell all of the rows, but only the numeric columns. So it's stored in numdf, a smaller table with just the numbers. Okay. So that is what it is doing, and par mf row, that is equal to c3 comma 3. That means telling r to draw the multiple plots on one screen, 3 row comma 3 columns. Okay, that is what we want to do. Now we are looping to draw it out using the for loop. Okay, so using the for loop we are doing, so we are taking it hist. So hist num, that is it draws a histogram for that column, and main equal to paste hist of, that is add the title histogram of column name, like that. Okay, that is how I want it. And X label we are just giving, and color we are choosing light blue, and there I want a border that is black. And basically we want to just reset the plot grid, that is par mf row, that is we are taking it 1 comma 1. So after plotting multiple graphs, resetting the screen to one plot per screen, that is what we are doing up here. So now let us plot it. So here we have got all of the plots together for all of the IDs. Here basically the data are really small. So you can see small, really small bars. So that is actually giving the idea. So if I am just checking it for 2, comma 2, okay, let's just run it. So we have got the same, but the plots are coming in this way, right? So that is the basic idea. Now we are just going for a bar plot for categorical variables. So now let us just run it. So here, okay, this is coming for his. Just a moment. Now let's just run it once more. Why it is not coming? Just a moment, guys. Let me just check this. So we have got this. Now we are just going it for this one. So we have got the values, but why it is not taking? Okay, let me just switch it off and then start again, I guess. Yes, so I'm taking the history off and then again plotting it down, like taking it down. Okay, fine. It's coming like that. Let's check this for this one. Why not coming? Let's check for another. Yeah, fine. I guess there is the issue somewhere. That's why it is not coming. So we'll check it there. Okay. So this is basically the box plot for numerical column versus the heart disease. So you can check that it has HAL CH versus heart disease. Next, heart disease is, of course, the disease that there is heart disease or not. Zero or one plus. Zero means there is no heart disease, and one plus because the data contains zero, one, two, three, like that. Okay. So if it is zero, that is there is no heart disease, and one or more than one, it gives yes. So here we have just given the label like that so that it's just giving us the data like that. So this is how my data are showing for each of the values. Okay. Now I am just going to get the correlation matrix. Okay. So I want to get the correlation matrix. So this is the correlation matrix for all, like how they are giving. So the negative one actually tells like for ID with ID, we are getting the correlation value as 1. With ID to age, we are getting the correlation as zero point 0.2. So with ID to cholesterol, we are getting minus values. So that means they are negatively correlated. Now here you can see like with T-RES BPs, with T-RES BP, we are getting the value as 1. Again, if we are checking for T-RES BP with HAL CH, there is a value that is negative. With TRES BP with old pick, there is a value that is zero point 0.1. So we can check for that. So this actually gives us the correlation altogether. Now we are just taking it. So here you can see the plots. So here basically you are getting the plots altogether. Like what are the value wise how the plot is going. Zero with zero, it is going like this. Two with like this might be anything in between. So maybe 0 to 4, 0.2, 0.2 with zero point 0.2, that is giving a better correlation. So of course, because ID with ID gives us the correlation as a one. Age with age, you can get the correlation. So we are getting a diagonal formation. So that is what it is showing. Again, the major you can see here with orange bars, major orange bars. So here you can see for them also the result is good. That is num with old pick, num with num like sorry, old pick with num gives the highest correlation, that is 0.41 like that, and other things are going good accordingly, right? So this is basically like that. Now we are going for plotting a heat map. So this is a heat map that we have plotted it up. Now we want to get the axis label. So here you can see the axis label. So basically what we are doing up here, like basically what we have just taken in case of this plot, like this above plot basically. So the bar plots, I guess you have already checked about the bar, like the bar plots and the box plots. So the bar plot was not appealing to that way, but the box plot was doing good, right? Now here what we are doing, here we are just plotting it accordingly. So we are just getting here the image because the image of that we have taken. Now we have taken one dot encall format like that we are using. So that is basically this one basically for x-axis, and this is actually the number of columns and the correlation table, and this is how the things are working for this. Okay, now here what we are taking, we are just going ahead to plot a density based plot. Okay, for this one, we want a density plot. So basically a density plot is like the smoothest histogram. Instead of bar we dot the smooth curve. So the taller cars have the more values in that area and helps to see the shape of the data easily. So we are going with accordingly, right? So here basically we are just taking it in that format. We are just taking adding the access label, and based on that we are moving. So let's just run this. And this we have added all of the labels up there for this one, because after the heat map there is no labels altogether, so we had to add all of the labels and the names so that the data are clear and we can just take it accordingly. So here you can see like this are the values that is going good. Also this dark colors are giving the major values. So 0.24, 0.24, 0.24, 0.24, these are the values that we are getting. Now we are going ahead for a density plot. Okay, yeah. So the density plot based on ID with the density, the ID with age, ID with TRES, VPs. So all of the numerical values that we have taken, so numerical columns, with that we are just going and getting the density. Now what we are doing, we are getting the scattered plot for age versus cholesterol. Okay. So we are just taking it. So this is how my plot is coming. This is the similar pattern we have already seen when we have just plotted in for Python. So the same way we have just taken it. Now we are just taking age with the maximum heart rate. So we are just taking it and plotting it. So this is the plot that we are getting with age with maximum heart rate. Now we are going for cholesterol with T raised BPs. For that, for this specification, we have just used this coefficient, the co-matrix, like the before that, this correlation matrix, this set, and along with that, the heat map that we have taken. Okay. Now we are just going for box plot for age versus disease. So this is the box plot. Still, there are somewhat outliers that are remaining for this specification. So we need to just have a look over that, or we just need to just change this to one single. That is one, two, three. Heart disease. That is one. There is outlier that can be visible. Coming down to heart disease 3, there is some outliers, and heart disease 4, there are also some outliers that we can see. Now we have to just go for cholesterol versus heart disease. So this is how my data is. The major outliers lies in zero that we need to again take and accordingly, right? So next we have the maximum heart rate versus heart disease. So here for 0 and 2, we are getting some of the outliers when we are putting thal CH over heart disease. Now we are just going for a pie chart for categorical column, but for gender, we are just first taking it up. So we are getting the females with blue and pink with male, like that it is moving. Now we are just taking the chest pain types, different chest pain type with the help of pie chart. So what is the count? So we can see asymptomatic is more, then coming down to non-angina, then atypical angina, then typical angina. Next, exercise-induced angina, how that is taking with the help of pie chart. Okay, with the help of pie chart, we are just taking that. So false is more and true value is less. And this is the final pairwise plot that we are getting. Yeah. So this is the pairwise plot that we have got for all. So this is all in details about the R programming. Okay. So by the time I guess you have understood what is in details about this R programming, and we have in details discussed each of the stuff so that you can understand how to plot it, how to work with our program, and how to just go in details with that, right? So this is the entire idea. This is how you have to work. And then what are the outliers are there that you can treat it, or because some in some points you can just we need to first validate it. If that is okay, that is good, else we have to just remove it. So that we can do for the positions where we have got some of the outliers. Okay. So my intention is to show you how to just take the data directly from from a raw data from there, do some of the pre-processing like the removing the missing values, checking in every step how the missing values are changing, then identifying about the duplicate values, then treating the outliers in some of the specific rows where specific columns where we are getting the major outliers, also going down how to just handle the missing values, treat the missing values, and just gain the numbers accordingly, and thereafter going down for the plotting different visualizations. Okay, and from the visualizations we will be getting some of the better insights, and from there we have to again do some of the work, and then we have to again visualize. This is the entire idea. Okay, so this is how the thing needs to be taken. Okay, I guess you have understood all of these sections and details, right, guys? So we will just stop it here. We won't go further from here. So we'll just like complete our session, like wrap up our session today here. We'll not just continue from here. So from the next session, we will be moving down with the ETL. ETL is a very important portion that we need to discuss, and then we will be moving down with Power BI, and we'll understand how to work with Power BI, how to get the plots accordingly, like how to get the what it's called the dashboard basically, the dashboard properly in Power BI, and how to work with Tableau and to get the dashboard ready for dashboard Tableau dashboard. Okay, this is what you need to take into care, and then we will be just going ahead. Okay, so this is how we will be going ahead. So this is how my our sessions further sessions will move, containing all of these details. Okay, guys. So we'll just connect in the next session accordingly. By the time, keep on practicing the Excel part. keep on practicing the SQL part, whatever we have just discussed. Just make sure that you keep the things practicing, because at the end you have to just work it all together. Like you have to just get the data from say SQL, like the data, no, sorry, from the database. Then you have to just go and understand some of the queries. Just do the some of the queries in SQL, get the data from Excel or any other source from the database as well, and just do the pre-processing and the further evaluation using Python or R programming, and then you need to just visualize that in the dashboard. Okay, all of the plot needs to be well integrated in the dashboard. I guess we have equally have a proper idea how we can work with an Excel dashboard. The similar way we have to prepare the dashboards in Power BI and Tableau. Power BI is quite easier to go for. Tableau is a bit tricky, but it's fine. You can take it. But as you all know, for Tableau, it is the paid version, so we will be using Tableau Public for that. So there, some of the operations and the tools are lesser as compared to the Tableau paid version. So if you have the Tableau paid version installed in your system, like the Tableau desktop, that is well and good. If not, kindly install Tableau Public. Along with that, kindly install the Power BI. Like, let me just show you the interface of Power BI so that, yeah, Power BI desktop. So this is the complete free version of it. So let me just show you that. So we will be just going ahead and understanding this, and we will be just getting it accordingly. Okay. So, okay. So this is the one. So I can show you one dashboard that we have created using Power BI. Okay. It's taking a bit time to load. Just wait, guys. Okay. Sorry. Okay. Fine. It's loading. Just a minute. So this is the plot that we have taken. So we have the sales dashboard 2025. So this is how we have to create it. So this is of course like the as we know, it is interactive at the same time. Like if we are changing it, it's the data are changing, right? So now we suppose we want any of the specific locations data. Suppose Bihar's data we want, or we want Goa's data, or we want Uttar Pradesh data. So this is how it will work. Okay. So this is all about this dashboard. So we will go from scratch and prepare this kind of dashboard. This is one data we have taken. So we will be taking some different data and we'll work with that. Okay, guys. Hopefully things are clear to you, and we will be just taking it all together, taking it all together in the next session. And first, we'll complete the ETL. What is ETL? How it is used? How the things are working? That we will be understanding. Then we will be jumping off to Power BI and then dashboard. By the time, guys, kindly just install Power BI desktop, the free version of it in your system, so that we can just move it accordingly. Okay. So thank you everyone for connecting in today's session. We will be continuing the session accordingly. Just have a proper space on for that and keep on just going ahead with this and keep on practicing. Okay. So thank you everyone. Bye.